Traditionally, if you had to install applications, then the first thing that we had to do is to create either a virtual machine or a physical machine. Once the machine is ready, you will then have the dependencies installed, and then the application sits on top of the dependencies. So we are here creating multiple layers, starting from the application, dependencies, then the operating system, and finally the hardware which it talks to. Now, containers and virtual machines have a similar resource isolation and allocation benefits, but they function a little bit differently because containers will virtualize the operating system. The virtual machines will virtualize the hardware. Containers are more portable and efficient. Now, as you see in the picture here, there is a container managing application like Docker, which can manage multiple containers. Each container will then host application and its dependencies. As you see in the picture, application 1, 2, 3 have different set of dependencies or binaries or libraries, but still they are sitting on the same virtual machine. They are isolated with the help of containers. The green, orange, and red boxes on the right-hand side are containers, whereas on the left-hand side, the same colors represent virtual machines. The one on the right side is a containers architecture, where we have multiple containers sitting on the same virtual machine. Although they are in the same virtual machine, they are still isolated. The dependencies is the one which the container handles. In this case, or in this example, it is the container managing application like a Docker engine, which will let the communication happen between the container and the hardware infrastructure. Containers and virtual machines used together provide a great deal of flexibility in deploying and managing the applications. So, containers are an abstraction at the application layer that will package the code and dependencies all together. Multiple containers can run on the same machine and share the operating system kernel with other containers. Containers take less space than virtual machine, whereas virtual machines are abstraction layers on the physical hardware, which can turn on server into many servers. The hypervisor will allow multiple virtual machines to run on a single machine. Each virtual machine includes a full copy of the operating system, the application, necessary binaries and libraries, which will take tens and hundreds of gigabytes together. Virtual machines can also be slow to boot. But if you look at containers, containers are very quick. They can handle several applications and require very less virtual machines and few operating systems. So containers and virtual machines have similar resource isolation but function differently because containers virtualize the operating system instead of virtualizing the hardware. Containers are portable, efficient, and very quick in running the application. So Docker. So container is a standard unit of software that will package your entire application code and its dependencies so that the application can run quickly and reliably on that virtual machine.